Hello and welcome back to the lecture of time series econometrics. In this lecture and next few lectures, we are going to deal with the mathematical properties of AR and MA series of higher order. We will dedicate one specific lecture for each of these individual properties. So in this lecture, we are going to first talk about the mean for AR2 model. Now, when we talk about AR2 model, let me just write down the standard form of AR2 model. So YT is equal to phi 1 yt minus 1 plus phi 2 yt minus 2 plus epsilon t. Okay. So now if I want to get a mean for this series, what I need to do is I will take expectation on both the sides. So which means expectation of yt, I will have phi 1 out, expectation of yt minus 1, phi 2 out, expectation of yt minus 2, plus expectation of epsilon t. Now you remember that in case of higher order AR models, we always assume stationarity first. So we assume stationarity and then see what is the result that we get. So if we assume stationarity, so that means expectation of yt is going to be some constant mu, and then I have phi 1, and this is also going to give me a constant mu because mu itself is constant. Then I have phi 2 mu, and then of course this is 0. So which means I have mu equal to mu phi 1 phi 2. So which means I'm going to get a result which shows that phi 1 and phi 2, phi 1 plus phi 2 is basically 1. Now, is it something that can actually guarantee that my AR2 series is stationary? If you remember in the last lecture, we actually derived a property where we said that from the root of the polynomial for AR polynomial, so we saw that this phi 1 plus phi 2 has to be less than 1. We know this property that's already given for the stationarity condition to be satisfied. So this has to be already, this has to happen for the series to be stationary. So which means this one is actually, we cannot really accept this one. So that means if that is the case, the only possibility is that I have to have a mu which is 0. So that's the only possibility I have. So only if mu equal to 0, I will have my AR2 series stationary. Now there could be another case where you can actually assume a delta or some constant term like y0. There's some value for the y0 term. So in that case, we can write something like, let me again, write it down. So I can write, say, y, let me use the same color. I can write yt is equal to delta plus phi 1 yt minus 1 plus phi 2 yt minus 2 and epsilon t. Okay. Now you take expectation. So expectation of yt you take, and here you have delta. So delta is constant. Expectation of delta is nothing but delta. Then you have your phi 1, expectation of yt minus 1. Then you have phi 2. You take it out, phi 2, expectation of yt minus 2, and then you have your expectation of the error term, which is nothing but 0. So then you have, so again you go back to the assumption that the series is already stationary. So if that is the case, then I have its mu delta plus I have, say, I take mu common, and I have phi 1 plus phi 2, right? So then I can take mu on the left hand side. So what I get is mu to 1 minus phi 1 minus phi 2 is our delta. So that means my value of my mu is nothing but delta by 1 minus phi 1 minus phi 2. Now you see, given this derivation, given this equation that we have just derived, I cannot have a value phi 1 plus phi 2 equal to 1, right? So the same uh, condition that we have just explained has to be satisfied here as well. But if I have a constant term delta, then I will have a value for mu, which is again constant, right? In same vein, actually we can also construct the mean for a AR model or AR model of nth order. So in that case, it will be just a simple extension of what you have just done. So what we will write, let me use a different page here. So I will sort of use an extended, just let me use the same color. I will use a higher order AR series where, let me use the delta also. It doesn't make a difference. You can, like assume delta equal to 0 as well. So it is yt minus 1 phi, phi 2 yt minus 2 phi 3. Seems some problem with the stylus. Phi 3 yt minus 3 and so on. Say phi n yt minus n. Okay. So it's just a simple thing. So here again, if you take expectation, so basically what happens is expectation of yt, which is mu, is basically you take expectation of delta, you have delta common, delta constant, and then you have basically all yt minus 1 and everything that will lead to a mu, right? So you can actually write mu of phi 1 plus phi 2 plus dot 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 dot. You have phi n here, right? So then you have basically what you get is here also expectation of yt is nothing but mu. So mu, you get it common and you get phi 1 minus phi 2 minus so phi n is equal to delta, which means you have your mu equal to delta by 1 or I can just take it like this, phi 1 plus phi 2 plus dot 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 phi n, right? So that's basically your value of the mean for nth order AR series. You can use delta equal to 0, then your mu equal to 0, so there is no problem. You can have delta equal to some value. In that case, you will have some constant value for the mean. And of course, the term below phi 1 plus phi 2 or phi n, that summation should not be equal to 0. It should be less than 0. Should not be equal to 1.